Hello, Chem 1A. This is Chapter 1, Lecture Video 6, and we're going to be talking about significant figures in this lecture video, and the next one, too. So, we take a measurement down. How many decimals do we use, right? Do we do a calculation with measurements? This all is based on how good your measurement was. If you are able to measure precisely out to a very far point, then you need to record decimals out to that point effectively. All measurements, though, have some uncertainty. If we think about a graduated cylinder, right? So here's my bad image of a graduated cylinder with lines at every 1 milliliter. So each one of these is 1 milliliter, right? So this would be 6 milliliters, this is 7 milliliters, this is 8 milliliters, this is 9 milliliters, and each gap between the lines constitutes a 1 milliliter gap. Now, when we read off of a graduated cylinder, we always read from the very bottom of the meniscus right there, right? So if I were to record this, we always take whatever the increment that our glassware or instrument measures with and then estimate 1 decimal place further. So since every line is at 1 milliliter, I'm going to estimate this volume to 0.1 of a milliliter. Now, in that scenario, what am I certain the volume is for? For sure, I know that we have at least 7 milliliters in this container, right? Because we are definitely above the 7 line. We're also below the 8 line, so I know we don't have 8 milliliters. I would estimate the next decimal place, being where that meniscus is, to be probably about 0.5. So this is 7.5 milliliters. Again, the second decimal place here, or the 0.5, is my estimate for the volume. I am sure of the 7. Now, we can't just stop here because 7.5 doesn't mean anything to anybody. We need to include our unit and have milliliters there. So whenever we're using a measuring instrument, we always estimate 1 decimal place past whatever the instrument gives us. This brings in what we call significant figures. Every digit that we record in a measurement, which is basically all the certain digits plus that uncertain one that we have to record as well, the 0.5 in the last example, is a significant figure. Significant figures are only for measurements. So if I take a measurement, then that's going to have significant figures. And when I do calculations with my measurement, that's where the significant figures are going to come to be very important. However, things like exact numbers, or what we call exact numbers, do not have significant figures, and therefore we do not need to worry about them. What are exact numbers? Exact numbers are counted values, right? So if I count, hey, I have 30 students in this room. I wish, right? I wish we were in person. If I counted 30 people in a room, I'm pretty confident in my ability to count to 30. There is no uncertainty there. Or if I counted how many sodas are in my refrigerator, again, pretty confident that I can do that without having any uncertainty or error. Another thing that is an exact number is a defined value. We define 1 kilometer as 1,000 meters. There is no uncertainty in that number. There is no error in that number because that conversion is a defined conversion. So when we're converting units, typically we don't have to worry about significant figures. It's when we take two measurements and we add them, subtract them, multiply them, divide the two measurements that both have significant figures that we have to worry about significant figures. So one of the first things we need to be able to do is we need to be able to determine how many significant figures are in a number and which of those digits in the number count as significant and don't count. So the first thing you should know is that all non-zero digits in a number are significant. So if it's not a 0, it counts for sure. Zeros are the hard part. Trapped zeros count. So let's talk about what a trapped 0 is. So if we look at this first number here, there are no zeros. All three of those are non-zero values. So there are 3 significant figures because we have 3 non-zero digits. In this one, none of these are zeros either. So we have 4 significant figures. And here's the first one that contains what we call a trapped 0. A trapped 0 is a 0 that is between 2 non-zero values or 2 significant values. So if we have a 0 in between two significant figures, that 0 is also significant, making this number have a total of 4 significant figures. This number here has 3 non-zero digits. They all count. They're all 3 significant figures. All right, so let's look at another scenario. Zeros that start a number do not count. All right, so if we're looking at these numbers, we can count significant digits as well. Again, the zeros in front of the number, they don't count. So this number here only has 2 significant figures. This number here, again, these 3 zeros are starting the number. They're in front of the number. They don't count. We still only have 2 significant figures. Here's where it gets a little tricky. This third number contains zeros that are significant and aren't significant. The 2 zeros that start the number, they don't count. But this 0 here is a trapped 0, so it does count. This number has 3 significant figures. This 0 is starting the number again, 3 sig figs in that number as well. All right, so let's move on to the next rule. Zeros that end a number without a decimal place are not significant. The reverse of this is also true. Zeros that end a number with a decimal place are significant. So if we have a decimal, they count. If we don't, they don't. All right, so this number here has 2 zeros at the end. There is no decimal at the end of that number, so there are only 1 significant figure in this number. Those zeros do not count. The same thing is true for 2700. These zeros are at the end of the number. There is no decimal place or decimal point. They don't count. There's only 2 sig figs. This 0, however, has the decimal. The only reason to include this 0 is if it's significant, because 16 versus 16.0 is exactly numerically the same. The reason why we include the last 0 is to indicate how accurately we know the measurement. So this, all of them count. We have 3 sig figs. In the same thing here, all of these count because these are at the end of the number with a decimal, and this would count as a trapped 0 in that regard, so 4 sig figs total. All right, let's talk about our last rule. A non-significant 0, we can make it significant by putting a bar over it, or converting to scientific notation, which we'll talk about in the next lecture video, or in a later lecture video. So for instance, let's say, hey, I measured 300 something and I only know it to 1 sig fig. Well, then that's how I would record this. But what if I actually know it to the tens place very, very accurately? Well, then I need to make this 0 significant. I can do that by placing this bar over the 0. This number has 2 sig figs. If I know it to the ones place very accurately, then I would place the bar over the thirds, this 1 0, and I would have 3 sig figs here because that would make this a trapped 0. Finally, if I know it to the tenths place, then I can just put a decimal place and say, hey, I have 4 sig figs here. All right, so as always, if you have any questions, please come talk to me via email or office hours.